Hello, how are you? Nice to see you another day here. Um, Today we have a very interesting day. Today we're going to learn how to resolve games with Prolog. Let's go to resolve some type of games that is called state problems. Are very common in artificial intelligence. There are many different types of these problems. We can solve, for example, a muscle, um, uh, similar games. We're going to start today. Let's take this Missionary and Cannibals problem. I'm going to share my screen to see you one example of this exercise, because I don't know if you see this game before. Um, okay, let me 1 second to try to find some Missionary Cannibal game. This one, probably the sound will be too high. Um, the idea of this game is we have 3 missionaries and 3 cannibals in one side of a river, and we have a boat. And the idea is move everyone from left to the right, or or right to the left. It depends of the game start, and without some restriction, like it's not possible to have in any place in the right side of the river, of the left side of the river, more cannibals than missionary, because otherwise, if there are more cannibals, cannibals can eat the missionary. So this is the restriction. We're going to move people from one side to the other side, but with the restriction um, of don't have more cannibals than missionary in any place, and the boat can only move 2 people at the same time. Let me see if this link works with the game. If not, I can try to write you an example. It's not here, I'm sorry. Okay. Sorry. Where is this room? Now, can you see the screen?
Yes.
I'm sorry for the volume before. Uh, this is the initial situation. This is the initial situation. There are some, this is angels, like our missionary, and the other one are cannibals. We have everyone in the right side of the river. We have this boat, and we need to move everyone, all people from right to left, without lose anyone. And if in any place there are more cannibals than missionary, cannibals can eat the missionary. So, for example, I would try to do one example. try to put, for example, one person, blah, blah, blah. And here at the same, there are no problem. But no, oh, something like that. You have to choose these movements. Try to have always more missionary or the same number in left and right, because otherwise we can lose people in the way. Okay, this is the idea. This is the idea of this game. Try to choose what is the sequence of movement to pass all these people from one place to other place. Okay, this is the idea. And now I'm going to show you how this type of problems work. Like this state problems works. There are typical problems of artificial intelligence. I don't know if I told you before, but Prolog is a programming language that are usually used to resolve artificial intelligence problems. Are problems that are related or similar that we can do, that brain can resolve. So the idea is define some states. Like you can imagine, for example, cheese board with all the piece, the initial start position. You can see how each time you make a movement with this cheese board, you can take a new picture of the situation. So we're going to have a second of pictures of the game from the beginning to the end. Each picture is a state of the problem. It's like representation of what is the situation of this game in any moment of this game. So first part to resolve one state problem is define the state. This is the first part of the problem. Is I have to take a picture. Have to take a picture of the problem in any time. So I need to put inside a predicate. We call this predicate state all the information we need to represent the problem. So, for example, in this case of the first part is there's a state problem solving. The first part is to define first part is to define the state. And the state will be something like that. It will be a state and parentheses and something inside that can describe with the information I write inside the state will be possible to represent, to make a picture of the problem. For example, in the case of Missionary and Cannibals, what is the picture? We have a picture like this. We have a river. Sorry. We have a river the middle, we have a boat, and here we have 3 missionaries and 3 cannibals, and the boat will be, for example, here. That will be the situation of this problem. So we have missionary, cannibals in one side of the river, and the boat at the same time in one side of the river. So I have to take this picture of the problem. Which information do you think I can put here? For example, we can say, okay, we have missionary and the left, cannibal and the left, missionary the right, cannibals in the right. And where is the boat? The boat is in left or the right side. That will be a first approach of this state. The information initially, for example, our state will be something like that. State at the beginning was 0, 0, 3, 3, 3, and right. Something like that will be the initial state, where we represent, we have 0 missionary in the right, 0 missionary in the 0 cannibal missionary in the right side of the river, 3 and 3 missionary cannibals in the right, 0 in the left, 3 in the right, and the boat in the right. So that will be the definition of the state, and the initial state. This is what will be our final state. Our final state will be the state that will be initial state. That, and the final state for us will be something like what we want. We want to have 3, 3, 0, 0, and doesn't matter, but I can write here, for example, something like that, or probably at the end the board will be to the left, something like that. That will be the final state. Is what I have to put inside this parenthesis, what type to define the, or with the information I write there, I can draw a picture of the game. Okay, you understand that? Any question? It's clear, more or less. The idea of the state is a way to represent the game. We try to simplify as much as possible. Here we put only relevant information. It's not necessary to put what is the color of the, I don't know, of the dress of the people there. We only have to put here the relevant information, most relevant information. We need to resolve that. Okay, nice. So this is the first part to resolve the problem, is what is the state and the information inside. In this case, we can reduce this first approach. That would be the first approach. First approach of the state. Do you think will it be possible to reduce the information inside the state or not? Will it possible to put a more simple state with the same information? What do you think? Will it be possible to reduce the information there inside the state or not?
We may use the difference between, for example, ML minus CL, MR minus CR, something like that.
Yeah, yeah, it's possible to reduce, and it will be more easy after to resolve if a state, for example, let's go to this second approach will be, for example, on a state where we only write, for example, the missionary to the left and cannibal to the left and the boat. Because if we have the information how many people are in the left, we can resolve what is the number of people we can have in the right side. So with only these three elements here will be enough to make a picture of the game. So it will be better if we can reduce and make this state as simple as possible. So for us, we're going to use this state because that will simplify the implementation of the solution with only this more simple state. Okay, we're going to use this second approach. Initial state will be initially we have 0 0 and right, and the final state we want is 3 3 and whatever, doesn't matter. Okay, what is our initial state and our final state? Okay, for example, if we want to resolve another type of game, for example a cheese game, what will be the initial state? And let's go to think a little bit on other type of problem, like for example cheese. What what is let me see one second. What will be the initial state for cheese? We have to represent this board. This will be our initial state. After that, we have movements. We can move piece from one place to other place. And at the end, the final state is the state where the game finished, like we kill the king. But in the case of cheese, the state will be something like a list of position with 8 by 8 position, like we have position, I don't know, 1 2 3 4 5 blah, 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 blah. It's a list of list with the board representation is like 8 by 8 that will be the representation of this board. In case of cheese, the state will be this list of this 8 position, and inside each position we have any piece. For example, here we have the P, blah, 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 whatever. Here the tower, the horse, and so on. And the same here. The last one will be the tower, horse, whatever. Okay, this is the way to represent the state in the case of cheese game. In any different game, we have to choose this representation for the state. Okay. Okay, we're not resolved the cheese now. We'll try to resolve this Missionary and Cannibals, but this is only an example for you that can help you to imagine how to resolve another type of problem using the same idea of state problems. Okay, nice. So we have the first part is this state problem, and next part is define. Second part is define the movement, because we have this picture of the game, and we can do some movements. In the case of Missionary Cannibals, what are the movements we can do? Let's go to imagine, to think about that. What are possible movements we can do? For example, I can move one missionary from left to right. No, that will be one movement, one missionary. What more? I can move one cannibal. What more? I can move one missionary and one cannibal. No. I can move two missionary, two cannibals, and so on. And from left to right and from right to left is that there's possible movement. One missionary from left to right, or two missionary, move two cannibals, no? Okay, this type of movements, and the same from right to left. So we have here 1, 2, 3, 4, 5 movements, and then I can have another 5 from right to left. In total, 10 movements, no? 6 are the same, but changing from the direction. And here, instead of do from left to right, from right to left, from right to left, right to left, and so on. Okay, so in total we will have 10 movements. One, two, three, four, five. Okay, this is the movement, and at the end we will have 10. We will have something more. You think we will have more movements or not? That's all. It's okay. You think we can have more or less? What do you think? Take your time to take a look at the list of movements and think if we need more or less. It's okay.
Maybe we can put move 1 and 2 together, but I'm not sure because
in the boat we only can have two people.
Yes, but
at the same time.
So can we have also only one person on the boat, or do we have to have two?
We can move one or two maximum.
Okay. Yes, I thought because
Not
if we
more.
if we would have only two, then we could have put move 1 and 2 together, but I think I understood it wrong.
We can move one or two. Will be two missionary, two cannibals, one missionary, or one cannibal. From left to the right. One cannibal. So I think this is the 5 or 10 options to move. One missionary, one cannibal, one missionary, one cannibal, two missionary, or two cannibals. There are no more options to move. Okay? Do you understand the game, the idea of the game, or not? Okay? Okay, nice. So there are 10 movements. After that, we have to implement the movement. The predicate movement will have always the same structure. Like the name will be move. It's very important to have always the same name of this predicate, because otherwise unification cannot work. So we need move, parentheses, and then the name of movement. For example, the first one is move 1, missionary. Missionary to the missionary to the left. I'm sorry, from left to right. To right. Okay, that will be the first name of the movement. Is move one missionary to the right. Okay, this is the first part of the movement, the name, because at the end, the solution of our problem will be a list of movements we have to do to go from initial state to final state. The solution will be a list of movements. So it's very important we have the name of the movement. Okay, perfect. The second part, second argument is the state before. A state, I'm gonna write, sorry, I'm gonna write here this like comment, move and name, we need the name of movement, the state before the movement, and what is the state, what is the situation of the game after the movement. So the movement will have the name, the state before, what is the situation before do this movement, and what will be the situation after do this movement. So for example, this case, for example, what is the state before? And in case of implementation of movement, we have to try it in the most generic way. So here inside, for example, I can have, okay, missionary to the left, cannibal to the left, and the boat. With this simple, the second approach of if what this is the situation before. In general, I have, this is a variable, I have here a number, I don't know what is the number, but I know I have some missionary in the left and some cannibals in the left. What will be the state after this movement?
The same variables, just another number.
We are moving one missionary to the right. What will happen here?
So
this?
ML is +1. Sorry,
Exactly.
-1.
Exactly. So what happened here is we will have a new, because I moving only missionary. What happened with the cannibals? Cannibals will stay the same. I'm not changing cannibals. And what happened with the boat? To move to the right, the boat initially had to be where? If I want to move to the right, if I want to move to the right, the boat have to be in the left. Otherwise, it's not possible to move people from left to right. So the initial state here, to move one missionary, we need the boat to the left. And then the cannibals remain exactly the same because we are not touching the. And what happened here? What happened here is that, sorry, what happened here is the missionary, the missionary 2 is here in our representation, this is the information the people in the left. If I move to the right, what happened with the people in the left? Will be what I have to do with the missionary in the left if I move to the right. is left -1. No? If I move to the right, what happens if here I have missionary in the left, I want to move to the right. So the number of missionary in the left have to be missionary -1. Missionary to the left -1. So here the state after movement will be ML2. And the boat, what will be the state after this movement? What happened with the boat?
It's right.
Yeah, have to be the right. Okay, that's all. Probably here we need to check things like, okay, what happened with the number? If I have not mission in the left, is possible to move or not? It's not possible to do, it's not possible to move, but we're going to solve that later, because we're going to define what means a valid state for this problem, and after the movement we're going to check if the state is valid or not. If the state is not valid, I cannot do this movement. Okay, everyone understand the idea or not? Do you understand the idea of this movement? For example, Benjamin,
Yes,
are you
yes,
there? Do you understand the idea of this movement? Yeah?
yes.
Okay. Everyone? Elsa? It's okay?
Yes, it's almost okay.
Sorry?
No, it's okay.
It's okay? If you have any question, please don't. Sometimes it will be difficult at the beginning. If you have any question, don't hesitate to make your questions, okay? Okay, nice. What happened here to solve this problem is we need 10 to create 10 different movements. That will be an option to create now 10. What is the next one? Move one missionary or move one cannibal. Can you try to do this movement by yourself in the same way? Try to do this movement by yourself in the same way as I did this first one. And after some minutes, we will see what happened. Okay? And if you have any question, you can try to resolve later. Take some time to try to write the 10 different movements for this problem. The first part of the movement is the name. Second part is the in state before the movement. And the third part is the state after to make this movement. Do you think you will be possible for you to create these 10 movements or not? Do you think? Would be nice this only create 5, only 5, the first 5, because the other are very, very similar. Create only the first 5 movements, okay? Okay, I'm gonna give you some minutes, 5 minutes more or less, and I will reconnect after that, okay? See you then, see you in 5 minutes to see what happened. See your question and your solutions, okay? See you. Do you have the solution? Any problem? Luca, Laura, the rest of the people, Floria, Alexander, Elsa, Liva, Natalia, Zawaska, Benjamin, Adriana, Dina, Mirna, y Milosh. Do you have the solution? Would be nice if more people participate. Well, Laura, you participate other days, but it would be nice if of the people that participate too. Do you have the solution? Yes, no? Do you need more? Yes?
Yeah,
Alexander,
Sure.
can you share your screen?
Yes, of course.
Someone who have any trouble to resolve that? Okay, nice. Let's go to see.
Basically, what I did is more or less copy the first one we did all together, and I exchanged here the new one, because if we just move one cannibal, then so just the number of cannibals changes. So I just did the statement. Same here with the version where we move in total of 2 missionaries or cannibals. And then here at the last, there's the mixed one where I update both numbers.
Perfect, perfect. To complete the other 5, what do you have to do?
Well, just copy and paste it and change it from left to right in every movement.
Exactly, exactly. Perfect. Left, exactly. Left there. Perfect. Very nice. The boat had to be on the right side. Perfect.
So,
at the end, after the movement, the boat will be to the left because we are moving to the left from right to left. So at the end, the boat have to be to the left. Perfect.
and we changed the.
You write double T in the previous.
Thank you very much.
Okay, perfect, perfect.
So
And
then
exactly.
Change the direction.
Exactly.
We add
Nice.
instead of
Okay.
subtract. That's it.
Okay. Super. We have the movements. There another way to do that more simple. Try to write less. It's very easy this way. Okay, let's go to continue. After that, I'm gonna give you another solution to more simple. But in this case, it's not complicated. It's only you have to write many different movements. Okay, but it's perfect. Next step. Any question about that? Everyone understand what we are doing here? It's okay? Perfect. Next one. Now we have movements. Next is, if we take here, next is the implementation of the path. Let's go to create a path to go from initial state to final state, and we're going to change to different states with movements from the beginning to the end. So let's go to create a path from the initial state to final state, using these movements to change from one state to another. So next step is implementation of the path. This is the third step. Okay, we are going to one initial state, and we want to go.
Could you share your screen again?
Yeah,
I stopped
yeah.
mine.
Okay, sorry. Okay. Now?
Yeah, thank you.
Can you see my screen?
Yep.
Okay. Here in the manual we have the next step is implementation of the path. In this implementation, we have to find a path to go to from initial state to final state. We need a path, and to get this path, we're going to use an idea to build the induction. Like, okay, I want to go from this initial state to this final state, and the idea is, okay, let's go to try to find a movement to go from the initial state to another state, wherever we call this state temporal or intermediate, something like that. So let's go to try to move from initial state to any new state, and after that, from this point, try to find a path to the end. And the property of this path is one step or one movement less than the full path. Here we have the induction because we have a path with one step less to the end. So the idea is, okay, we have in that initial state, and we want to go to the final state. But what we are going to do is first try to find a movement from in the state to a state we can call temporal or intermediate, something like that, if you want, or intermediate state. And after that, we are going to try to find a path to the end, to the final state. Okay, this is the idea. We want a path from the initial state to final state, but we're going to do that doing a movement from initial state to anywhere, any new state, and from this state we're going to try to find the path from this new state, intermediate, to final. Okay, the path will have the same definition. We need the initial state, final state, it's very important to have here the visited states. What more? And at the end, we will obtain the path. The path as a list of movements to go from initial state to final state. So what is the idea? That is true. It is true if path unify with the list of movements to go from initial state to final state without visiting states that are in visited list. What is the idea of this visited? The idea is we don't want to repeat the state. Why we don't want to repeat the state? Think about, we take this boat and we put, for example, one missionary and go with the mission to the left, and we have a new state, and then back with this missionary to the initial state, and then repeat again, and this missionary go and back always. That have not make sense to take this missionary from the right to the left and back, and then do exactly the same. We are repeating in this way. We are repeating states. We don't want to repeat the states. We want to always have different states in this path. So we are going to use this visited state list to avoid the repetition of states. Okay? Okay, now let's go to use induction here to create this path. What will be the most simple case, most simple path? What do you think will be the most simple path to resolve this problem?
If the initial and the final state are the same.
Okay, Alexander. Okay, perfect. That's all. That is. If initial state and final state are the same, let's go to see what happened. Initial state and final state, and I'm going to write in this way, initial state again, initial state. That means initial state and final state are the same. What happened with visited? Visited is a way to try to avoid loops, that try to avoid to have repeat exactly or repeat the same situation one time, another time. So if we are to the final, you are in the initial state and final state are exactly the same, we don't need this point that visited, because we don't have the option to make loops now. So here, what we have to put here is whatever thing. Doesn't matter for me what is the content of visited, because I'm not going to visit a new state. I am in initial state and final state the same. So doesn't matter here, because here we don't have problems to create a loop. Okay, and what will be the list of movements if we are initial state and final state are the same? Or I am already in the final state, what I want. What will be this list of movements? What do you think? What do you think? What happened with what will be the result for this most simple case? I want a list of movements to go to initial state and to initial state. What I have to move if I am already in the place where I want to go?
It's empty, no?
Empty, exactly, empty list. No movements because I am already in the place when I want to go. I want to go to the final state, or if you prefer, if you final state, final state the same. It's exactly the same, but probably final state and final state the same. Initial and final are exactly the same. So there are no movements I have to do. So the list of movements in this path have to be empty, because remember, the most simple case have to be true, and the only option to make that true is the list of movement is empty. That's very important to realize that this element have to be true. Next step. Now, what we are going to do is to try to go to from initial state to final state with a list of visited, and let's go to leave the result to the end, so empty, because we need what we have to put there depends on what we write after that. So first thing we're going to do is try to find a movement with one name of movement or move name from where? From initial state to which place? This movement have to be from initial to where? We have here.
This temporary step.
Yeah, let's go to move to this intermediate state if you want. Intermediate, what do I see? Intermediate state. Let's go to try. And then what we have to check? We have to check if this new movement are not already invisited. So we have to check that it's not member int, it's not a member of visited, because I don't want to repeat a state. So if this new state is in intermediate are already visited, I don't like that. So I only want a new state that are not in the visited list of states. And after that, what do you think I have to put here? You can help me to continue. Now we want a path from initial state or the final state. We are using induction, and we made a movement for initial state to intermediate. What do we have to do now? Can you help me to continue or not? What do you think? What is the next? Using induction. What we did with induction. Remember, we call to n-1. Here, we will try to, we want to go from point A to point B. We make a step, and then what happened with this new path is one step less than the full one. So what do we have to do now? What do you think?
Well, basically, we have to update the visited list and the list of paths with the name we got from the movement.
Okay, but now what we have to write? Yes, what the next? I need a path. No, I write here. If you go here, I say I need a path from intermediate to final. No? I want a path from initial state to final state, but we're going to do that using induction with from initial state with a movement to one intermediate state, and from there, a path to the end. So what the next? I have to write here. Who can tell me? Nope, no idea. Path, no? From where?
The temporary to the final.
Sorry? Intermediate?
To the final.
State. Perfect. That is the idea. What happened with visited? We have something new in visited respect to this previous list. So this one.
We have
We
the
visited.
int as a head and then visited.
Yeah, exactly. We have to put here before, because this is a new state. We started from here, we go to a new state. This new state is, I have to include in visited. So now we have a new, and at the same we did before with the rest of exercises here, we only said, okay, if that is true, what we have here, who can tell me? If that is true, line 81, that is true, what we have inside the path? Give me a description, it's possible, about what we have in the path, line 81. To give an answer, you only have to read this line from 71 to 73. Here is the explanation. What do you have in path?
That's this path we have in the initial state, but without the step we just did, no?
Yeah, but okay, that's true, it's a path, but what are inside this list? Path, what is path? Path is a list. They say that is true if path unified with the list of movements, of name movements, the name of movements. to go from initial state to final state. So here in path, we have a list of names of movements from to
So
go
in
to
the line 78, we have the list, and path is the tail, and the head is the movement name, no?
exactly. Very good. Very good. That's all. We finished. Do you want to check if that works? I'm gonna share. If you want to add to your code, probably I can continue. I need to put all the movements here, and that's all. Muy bien, no apagues la luz.
Que me voy a la cooperativa y al cementerio.
Wait 1 second to show you this code in the chat. If you want to put inside your code, because we finished. That's all. We have the state, we have the movements, and we have the path. The last step, next step, is implementation of the solution. Let's go to do that to finish. Solution predicate. The solution is very simple step. It's only a solution. We want a path. And what we need here is only to give me a path from what is the initial state? What is the initial state for us? State 0, 0, 0, 0, right, no? Yes or no? This is our initial state, 0, 0, right. We have all the people to the right and the boat to the right. What is our final state? Tell me. What is our final state? What is our final state?
It's 3, 3 left.
Exactly. 3, 3 left. What more? And only we need here a path, the variable path. And what happened with the visited at the beginning? Visited state at the beginning. What do I have to put here in visited? It's very important to write here the correct what I have to put here. What do you think? Initially, what is the list? What I have to put in the list of states? List of visited states. What do you think? I have to put here.
Nothing, no? Empty list.
We can put empty list or what is the initial visited state at the beginning? We have an initial state. So we can put here state, sorry, here state 0, 0. Right. Oh, it's the first one. Okay, I'm gonna give you, do you have the idea? I'm gonna give you this screen for you. Please finish the exercise and try to check if that works or not. Okay, finish, try to put all the movements in the same file. And here there are many information you have to comment because that are comment that is not part of the code. What more? This is not part of the code. This is an explanation. Okay, what more? This is not part of the code. This is not part of the code. From this line to this line. Remember, this is a block, comment block. When from here, from this symbol to this symbol, Prolog will ignore all the code in between. Here I write only, this is a comment, this is not part of the code. This is not part of the code, there are explanation, blah, 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 blah. And I'm here. But for this code, I only write one. Alexander, can you write your movements in the chat?
Sure.
To help the other people to create their own implementation using your movements and check if that works or not, and if you have any problem to finish this exercise. We have some minutes more before finish. Okay, so it's very simple to create these movements for yourself. Okay, so try to finish the exercise and check with Prolog if that works, okay? And after some minutes, 5 or a little bit more, I will come again to see if you have any problem, and we'll try to resolve that, okay? See you in 5 minutes. Okay, so I need one thing more is to define what is a non-valid state. For example, we have state is missionary, state missionary and cannibals. Sorry, cannibals on board. So what is not valid? It's not possible to have, for example, more cannibals here. It's possible to have 0, 1, but it's not possible to have 1, 2, and whatever. It's not a not valid state. What more? This is a not valid state. What more will be not valid? If the contrary, if they are more in the right. So what means will be non-valid? State if there are more cannibals to the left. Q1. Let me 1 second. I have the list here. So we have to check it's not valid. 2, 3. Because 2, 3, 1, 3, 1, 2, 2, 1, 1, 0, or 2, 0. With the list of not valid, we have to include here to say, okay, this new state have to be not valid. So that means this is a negation of that, so that at the end that means that it's valid. And I write this list of not valid because it's shorter than valid. That is a short list of not valid states. So it will be more easy, but you can do it at the same time if you want to write valid states. For example, you can think about the valid situations. And now I detect here we have to do something more, because in this case, we have to check here, for example, if we want to delete 1, ML have to be greater than 0, because otherwise it's not possible to delete 1. And here, same, ML have to be greater than 0. Here, ML have to be greater than 1. And here, ML have to be greater than 1, 2. And here, ML have to be greater than 0 and CL greater than 0. That will be, well, but otherwise it's not possible to do that. At the same time, in the other two the options here. Sorry. Do you think with this information you can resolve or not? Anyone have the solution? Can execute that or not? I'm going to copy this movement to the other 5 to the left. To the left. Left. And in this case is +1. +1, that means if I want to ML be less than 3. Less than 3. Less than what? 2 missionary to the left. Less than 1. Left. Menor que 3, mejor dicho. Less than 3. And here if I want to put plus less than 2. 2. To be 1 plus 2, 3. Okay, and here +1 and +1. That means M had to be less than 3 and less than 3 because I'm going to add 1, so that not can be greater than 3, so it had to be less than 3, less than 2, less than 2. I think that's all. And here the boat. And here we're to the right. Right, left. Right, left. Right, left. And right and left. Yes, and right and left. Do you want to see if that works or not? 1, 2, 3, 4, 5. Okay. Save that at PL. Okay, let's go to see if that works or not. Valid. Okay. Let's go to see what happened. I consult Missionary with notes. Okay, first let's go to resolve the errors here. First one. Okay, I have to close that because I opened before. I consult with notes. Okay. We have singleton variables, line 106. 106 here. But this is a comment. Okay, singleton variable in line 124. 24. Initial state initial state initial initial initial. Okay. Okay, no errors now. So let's go to try the solution path. See what happened. False. Why is false?
So I added the, like I said before, the empty boat from left to right and from right to left, and then I got a solution. Without, I also got false. So maybe it's that.
You get false or not?
No, I had it before, and now I added to the movement list that I posted before. I added an empty
Okay.
boat without the changes from left to
And
right.
can you share your screen to see the solution and finish?
All right. So like I said, I added this movement, the empty boat.
Okay.
These two lines here, and then I also get the, well, some solution. I don't know. Haven't checked if it's right, but
Okay.
at least it does something.
Okay. Perfect. Perfect. So we have to check if that is a good solution. But to finish the day, next day we will try to check some errors here. Check if the solution is good or not. Okay. But more or less we have everything. We did everything to resolve this exercise. Okay. We only need to check if the solution is really good or not. Okay. Perfect. Nice. Any question?
Yes, if we can get the topic for the exam so we can start.
The topic of the exercise, exactly, would be something similar to this one, to this Mission and Cannibals exercise, but okay, I'm gonna give you the next day. Will be good or not? How many classes we need to finish this month? No?
I think it will be better if we could get it now, because, for example, in my case, I have a lot of things
Yeah.
to do, and it would be great to get the scope and how to see what we should do.
Okay, if I cannot give you now, but can you send an email this week if you want? Tomorrow probably.
Yes, that would be great. I
Okay.
think. Yeah.
With with something similar to this one, probably a different type of exercise, but with the same idea. It's like create states and movements, and the same idea to resolve the very similar to this one. Okay.
Okay, great.
Okay, I'm gonna give you these days next and this week to have more time to finish. Will be not too complicated. I am a little bit worried about the rest of the people that usually don't participate in the classroom. I hope all of you are understanding. I hope you will not have any problem to resolve this exercise. Okay. Nice, perfect. See you next day. Thank you.
Thank you.
Thank
Bye.
you.
Thank you.
Bye.
Welcome.
Bye.
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 Bye bye.
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 Bye.